Good morning, students. Here, Professor R. Surendran from Government College of Technology. And today we are going to see some of the questions in manufacturing technology. In the first chapter, break-even analysis classifies the various cost. So in break-even analysis, what are the cost which is involved? So we are having two types of cost in break-even analysis. One is fixed cost and variable cost. That is the thing. So some of the fixed cost and variable cost is the total cost. Okay. For the typical manufacturing, the second question is for the typical manufacturing operation, the variable cost may include the following cost. So in variable cost, what are the thing we have to include? It is the part material cost. So in variable cost, based on the number of material, the variable cost may be changed. Setup cost is fixed cost, and tooling cost is fixed cost, and cost of die is fixed cost. But the material cost alone varies based on the number of pieces. So it comes under the category of variable cost. Next, for the typical next question, for a typical manufacturing cost, the fixed cost may include the following cost. So tooling cost. So this tooling cost and die cost come under the fixed cost. Other three costs are overhead cost is variable cost, part material cost is variable cost, and running cost is variable cost. So this is about the first chapter. The next chapter we will see. Next question in the next chapter, we are having strength of material can be defined as it is how the strength is can be defined. We have to know. So it is a strength is nothing but it's a resistance offered on the application of external force. So it can be defined. It is not resistance offered to the indentation. It is oddness. It is not resistance offered to the impact force. That is toughness. Resistance offered to sudden application of impact forces. That is also common to toughness. So the correct answer is option B. Strength of the material can be defined as the resistance offered on the application of external force. So when you apply some force, what happens? The material will resist. That resistance is called strength. Next, strain. Strain is the ratio of change in dimension to the of original dimension, dl by L. Strain has no unit. It is the ratio. Strain is the relative variable. It has no unit. So it is a ratio of change in dimension to original dimension. Next, Brinell hardness test uses an indenter, that is sphere made of steel or tungsten carbide. In Brinell hardness, we can use the indenter in the form of sphere. The material is made up of steel or tungsten carbide. In Wicker hardness, we are using the indenter. It is square base, pyramid, and diamond. Okay. So in Brinell hardness, it is. Next question, we are going to see the ductility of the material. The ductility of material can be defined as the ability to deform under tension. So we can look the options. It is a resistance offered to indentation. No, it is hardness. Resistance offered on the application of forces. It is strength. Resistance offered to the impact force. It is toughness. So the answer is none of these, because the option is not available. None of these. Pig iron. Next, we are going to see about the pig iron. In pig iron is the iron with 4% of carbon. So we can easily remember it is 4. The iron letter consists of 4 and a pig 3. So it will be more than 3. So it is 4. We can easily remember. In the face-centered cubic cell, FCC, the atoms are present at all 8 corners of the cube and at the center of each face. So in the center of each face, one atom is there, and 8 corners it possesses the atoms. Fine grain size. Next, we are going to see about the fine grain size during the solidification of the metal is achieved by. How the fine grain size is achieved? It is achieved by high nucleation rate with the lower growth rate. So nucleation rate will be I. So IN. So IN, high nucleation rate, but less growth rate, lower growth rate. So growth rate, you can remember G. So IN. So nucleation rate is I, growth rate is less. Maximum carbon percentage is up to is 2%. In steel, it should be 2%. In steel, it should be 2%. So in the next, we already know that in steel, the carbon percentage is less than 2%. And austenite is the FCC form of ion. So it is a gamma ion. Austenite is a gamma ion. Gamma is the face-centered QB. And the ferrite is the BCC form of ion. The ferrite is the alpha ion. It is a BCC form of the ion. In gray cast ion, what happens? The graphite present ion where part of carbon is in the graphite form. So because of gray color, the graphite is come because of the graphite color is gray. So graphite ion where part of carbon is in the graphite form. So that is the gray cast ion. In ductile ion, the ductility is made due to the spheroidal graphite present in the spherical form. Next question is 2.14. Next, we are going to see the chromium as the alloying element in the alloy steel is used principally to improve the corrosion and oxidation resistance. So chromium is suitable for corrosion resistance and oxidation resistance. Tungsten is the alloying element in alloy steel. It principally improve the mechanical property at elevated temperature. Tungsten is used for improve the mechanical property at elevated temperature. So you can easily remember in tungsten 10 T is there, TE, elevated temperature. Aluminum alloys are generally used for their excellent corrosion resistance. And martensite is the BCT, body-centered tetragonal form of iron. Tempering, in tempering, we know that it lowers the hardness. So first two options, but austenite to perlite or martensite to perlite. So we can, in tempering, you can MP, you can remember the word MP, martensite to the perlite. So it lowers the hardness by transforming martensite to perlite. In tempering, TEMP, that MP means M martensite, P1, P perlite. Non-basing process to achieve the improved mechanical properties by transforming austenite to fine grain perlite. Nitriding process is used to increase the surface hardness of alloy steels. Thank you.